Hey guys, this is Mr. Yo, and today what we're gonna go over today is called a gas law. So about gas law, there are a couple things that you need to know. Especially you need to know the standardized temperature and pressure. In another word, we call it STP. So in an STP, a couple things you need to know is that for temperature, we will always have a 0 Celsius. Now, if you guys don't remember how to get from Celsius to Kelvin, what we're going to do is always, this is the formula, Celsius plus 273 will give you Kelvin. So just by doing 0 plus 273 will give you 273 Kelvin. Okay, so that is for temperature. Now, for a standardized pressure, is when you have one ATM. Within one ATM, we have 101.3 kPa and 760 millimeters of mercury or torr. So these are the STPs that you need to know when you're solving questions using the gas law equations. So there are a couple rules or a couple regulations and laws that you need to know. First of all is the ideal gas law. An ideal gas law is when we have piv inert, or PV equals nRT. Now, if you guys don't remember what each of these letters stands for, P stands for pressure. V stands for volume. N stands for mole. R stands for the constant number, which will be shown as we scroll down to the page. And T is for Kelvin. Now, for the unit for each of them, pressure, it can be either ATM or kPa or mmHg or torr. Okay, just like mentioned on the top for the standardized pressure. Volume, majority of the times, it's going to be in liter. Mole's going to just be mole. Constant, well, depending on what your pressure is, your constant unit will change as well. Now for temperature, we always make sure that it is in Kelvin. So T stands for temperature. So keep that in mind. So that is ideal gas law. Now, next one is called a combined gas law. Now, the reason why they call it as combined is if you guys remember if we scroll down a bit, you'll see Boyle's and Charles' law. A combination of Boyle and Charles' law is P1 V1 over T1 equals P2 V2 over T2. Now make sure that you multiply the top and then divide it by the temperature. Now, we use combined gas law when there are comparisons. If there are two pressure, two volume, or two temperature. So just to make sure, P is pressure, V is volume, and T is temperature. Okay, so always keep that in mind. Now, when you're using combined gas law, we always make sure that this is in Kelvin. Now, for the volume and pressure, it really doesn't matter. You just need to make sure that when you're comparing the two pressure or two volume, they have to be the same unit. That's all that matters. Next, we have Dalton's law of partial pressure. This is pretty easy because what we're doing is pressure of the total is discovered by having the first pressure plus the second pressure plus the third pressure and so forth. So depending on how many pressures they notify within the question, that is the amount you will write down for that question. Now we have Boyle's law. Boyle's law contains pressure and volume. So we have P1 V1 equals P2 V2. Now, if you guys remember from our combined law, okay, just by taking out the temperature here, since it doesn't mention anything about temperature, there is your Boyle's law. So this is another easier way to understand, to figure out what Boyle's law looked like. Now, a couple things you need to know about this is that if one increases, so for example, if pressure increases, that means the volume has to decrease. Or you can say pressure decrease while volume increase. So it's always going to be the vice versa or inverse of each other. So in this case, the drawing will look like a down slope. Charles' law, on the other hand, is going to have V1 over T1 equals V2 over T2. Now, just by looking at the combined law again, okay, remember, in this case, we don't actually have pressure. So I'm just going to cross out the pressure, and the only thing left out is V over T. And that is how we figure out Charles' law. Now, the information about this one is that if one increases, for example, if a volume increase, that means temperature will increase as well. So in this case, we will have a rising slope or a direct relationship here. So make sure to know all these laws before you solve any questions. Now, moving along to the next one. What is the volume of 1 mole of any gas at STP? Within 1 mole, there's always going to be 22.4 liter. This is something that you have to memorize when you're working on a stoichiometry question. So keep that in mind. Next, what we're going to do is we're going to try to figure this out by solving the following. So what is the volume of 3.5 moles of carbon dioxide gas at STP? So a couple things what I'm going to do is first write your information down. So I'm going to say write info. So we have N or mole is 3.50 mole of CO2. So I'm going to use the train track system or the rail system, whatever you call it, and make sure that the first thing comes out to be the question or the given information. Next, the unit that you want to get rid of has to be on the bottom. So in this case, we will have mole on the bottom and liter on the top, since we're looking for the volume. Now remember, our volume for STP is 22.4, and that will always equal to 1 mole. So once you calculate this, you will get 78.4 liters. So always make sure about the sig fig as well. we have 3.50. So whenever you're solving these kind of questions, what I would highly recommend is look at the given information and check what is the sig fig for here. So depending on what sig fig you get within the given information, that is the sig fig you will use for your answer. So that's why we have 3 sig figs here. Next, we're doing the vice versa of it. So I'm just going to draw the train track or the rail system. Write down the given information. The unit you want to get rid of goes to the bottom, and the unit you desire goes to the top. So by solving this out, this should give you 1.92 moles. And that's how you figure out this question. Okay? It should be pretty simple because it's kind of a refresher from stoichiometry of things that you have used for grams, moles, and atoms and particles. Next is number 6, which should be pretty simple for you all, which is converting Celsius to Kelvin. So remember, negative 100 Celsius plus 273 will give you 173 Kelvin. That's 1. 0 Celsius plus 273 will give you 273 Kelvin. Now 37 Celsius plus 273 will give you 310 Kelvin. So there you have it. Pretty simple. Now on the bottom are the list of R values from the PIVNERT, our PV equals nRT, if you guys don't remember. The R value here are the following. Now make sure you remember this. For 0.0821, that's when you have the pressure of ATM. For kPa, you will use 8.314. For mmHg, you will use 62.4. So keep that in mind when you're using the R value. So let's try solving some questions. So like I always do, I always make sure to set up all the given answers or given informations and list them out. So in this case, we have first the volume, following with our pressure, which is 1520 torr. And then it says, what would be the pressure of this gas if it were allowed to expand to 1250 milliliter? So we're changing from 468 to 1250 milliliter. Then what would happen to the pressure? Now, if you guys remember PV, we have PV, PV. So we're just going to plug in those informations. Okay. Now, depending if your teacher wants you to write down the unit, please do write down the unit. I'm just writing down the numbers just to be quick. And P2, V is 1250. So if we put this into a simplified version, okay, that should give you 569 torr. So remember 3 sig figs in this case. So that's number 7. For number 8, I'm just going to do the same thing. So we have temperature this time of 300.0 Kelvin. occupies 6.50 dm3. dm3 represents volume. And we have pressure, which is 355 kPa. Now, what is the pressure? So what is the pressure if its volume is reduced to 4.80 dm3? Now, in this case, it never mentioned about, or it didn't mention about temperature for our second part. So that basically means is that we're just going to leave it as it is. So it's probably going to stay constant. Oh, I take that back. I forgot to read this part, which is 250 Kelvin. That was my mistake. So I'm going to use that combined gas law to solve this out. So make sure to write down the informations. Temperature is 300. Given pressure, that's what we're looking for. The volume is 4.8. And our temperature is 250. So we're just going to solve for P2. Now, if you guys are confused how to do this, what I usually do is kind of show you a work of how you got to that point. And then 250 divided by 0.80. So if you solve that out, you would get you would get 401 kPa. Okay. So if you are confused how I got this answer, please make sure to do this on your own using your calculator. Okay. Oops. Next, we have this. It says a balloon with a total pressure. So this total pressure kind of gives it away what kind of equation you'll use. So it says the total pressure is 753 torr. But the partial pressures that are given, so PNH3 plus PO2 plus PN2 will give us the total. So if I were to plug in those numbers, O is 175, plus we do not know the pressure for N2 is equal to 753. So I'm just simply going to subtract the total minus the partials to get the answer. So that should give you 325 torr as your answer. Okay. So if you need to review anything, just rewind or pause the video so that you can review this on your own. Next, we have, it says a gas confined in 0.515 liter. So I'm just going to put volume as 0.515 liter, and container exerts a pressure of 107.4 kPa at a temperature of 38.6 Celsius. But remember, we cannot leave Celsius temperature as Celsius, so we're going to convert that into Kelvin, which is 311.6. But remember, for sig fig wise, the sig fig is based on the decimal or after the decimal when you're adding or subtracting. So in this case, the right sig fig would be 312 Kelvin. Next, it says, what is the Celsius temperature will exert? So what is the temperature for the next one if the pressure becomes 635.7 kPa and the volume becomes 0.644 liter? So we're going to use the combined gas law. So I'm just going to plug it in instead of writing down the original formula. Okay, since you guys should be able to understand which equation we'll be using. Let's see. Also, when you guys are solving this, make sure to check the units if the units are the same. Okay. So what I'm going to do is I'm going to cross multiply. So eventually what it's supposed to look like is 635.7 times 0.644 divided by, actually times 312 divided by 107.4, 0.515. So once you solve this out, divided by 107.4 divided by 0.515, that should give you 2309 Kelvin. But since the question is asking for Celsius, we're going to subtract by 273 here. And that should give you a rough estimate of 2036 Celsius as your answer. Okay. So if that was too much, please make sure to go back and check how this has been processed out. Next, it says a spray can has a volume of 0.47318 liter, and the pressure is 0.35 atm. What is the pressure? Okay. If the can is run over by a garbage truck and the volume decreases to 0.01316 liter. So we're going to use PV. So I will multiply 0.35 by 0.47318. The pressure we do not know, so I'm going to put P multiplied by 0.01316 and solve for P. Okay. So try that out on your own. So that should give you 12 as your pressure. Perfect. Okay. Now for the next one, should be pretty simple. It says, what is the total pressure of a mixture if the partial pressure of a nitrogen, oxygen, and argon are this, and this? So we have a partial pressure of nitrogen, partial pressure of oxygen, and partial pressure of argon. So we're just simply going to add all of these numbers together to get the total pressure. So which will give you 99.68 kPa. There. Next, what is the Kelvin temperature at which 1.6 moles of gas has a volume of 20.6 liters at a pressure of 0.52 atm? So I'm just going to jot down everything. So temperature is what we're looking for. Number of mole is 1.6 mole. The volume is 20.6 liter, and our pressure is 0.52 atm. Now, we have every information, so also the constant number, since we're using atm, is going to be 0.0821. So remember PV or PV equals nRT. So P is 0.52, V is 20.6, N is 1.6, R is 0.0821, and T. So at the end, you will get a number of 82 Kelvin as your answer. So make sure to look at your constant number and make sure to look at the pressures unit to determine the constant number. All right, 2 more to go. So a sample of gas has a volume of 32.0 liters. The temperature is going to be 10 Celsius, but remember, we have to change that into Kelvin, which is 283 Kelvin. If the pressure is not changed, so pressure is staying constant, to what temperature must it rise to? So we're looking for the temperature in order to double our volume. Okay, so we're dealing with volume and temperature. So the volume that we have divided by the temperature that we have equals 2 times 32 is 64 divided by the temperature. So our temperature in this case is going to be 566 Kelvin. Now, if you guys are freaking out, why is our temperature so big compared to the other temperature? Well, because while your volume increases, your temperature also increases as well. So that is why our temperature is going to be larger than our previous one. And also, it says that the temperature was rising. So that is why the answer is 566. Now, last but not least, how many moles of NH3? So we're looking for the mole of NH3 makes a volume of 867 milliliter. Now, here's the thing. Volume has to be in liters, so I'm going to multiply this by 1 liter over 1,000, which will give you 0.867 liters. Now add a standardized pressure. So what I'm going to use is I'm going to use ATM, 1 ATM. It's just something that I use often, and I remember that the R constant is 0.0821. Now the temperature in this case is 50 Celsius. So in order to convert that into Kelvin, we add 273. So that should give you 323 Kelvin. Now plugging in the information, so we have pressure as 1 ATM, volume is 0.867, number of mole is N, R is 0.0821, and our temperature is 323. So figure out what N is. Okay. Which will give you 0.0327 moles. Now, the reason why this is 3 sig figs instead of 1 sig fig because of 1 ATM is because the 1 ATM is a defined number. If you guys remember all the way back from your lesson about sig figs, defined numbers are not counted as sig figs. For example, if we convert milliliters into liters, 1,000, which is 1 sig fig, is not counted as our sig fig parts. So that is why instead of saying 0.9, this is answered as 0.867 liters. And that's basically it. So if you guys have any questions, feel free to ask, and hope you have a wonderful day today.